much. They aren't too big, so these will be rather short. I'm not going to keep anybody from viewing later on tonight, so. Okay.
Hopefully next month I have time to actually put material together for a main topic or something, so it's not just one short presentation this month. Now that the recording starting, for those watching this after the fact tonight, we have only one presentation, and it is our constellation of the month given by Peter Hermes, who will be doing Libra and what else?
Norma.
Norma's a southern constellation?
Yes, it is. There were about, I think we've only had about, when we started, there were only about 7 or 8 left, and there was only one, well, they're all, in fact, all of them were southern that were left. Of course, Libra, I mean, Libra is still a southern, you know, technically a southern constellation, but all the rest of them are down south too.
Oh, I need to make you a co-host so I can actually.
Thank you.
I forgot about that. I was like, why? What's taking you so long?
I was just going to wait for a while and see what happened.
Just me kind of out of it tonight. You should have a co-host now, so you can present your screen whenever you're ready.
Oh, okay. Let's see, which one do we want? We want to go with this one first. And if I can make it presentation, there we go. Everybody see the screen okay? See the first part of the presentation?
Yes, thank you.
Okay,
Looks
very
good.
good. Thanks.
Yeah,
Hey,
right.
good evening. My name is Pete Hermes. I'll be presenting 2 constellations tonight. Shirley, thank you for your attention. There's not a whole lot of material in these. Libra, I've got Libra, and then I'll have Norma after this. Certainly, given that there's not a whole lot of material, hey, if you want to chime in, please do. Just yell at me. I've only got the one panel open, so if there's a hand or anything like that, I probably won't see it or see the chat. So just yell at me. But by all means, don't hesitate to do that. Just so you know, the one thing you see in the lower left portion of the this first screen, it sort of looks like a omega underlined, and that's the let's call it the archaic symbol for Libra. That's something that might come up later. But anyhow, a few details. You see a little bit of a star field and one presentation of the constellation. It is in the southern sky, but it's quite prevalent in southern Arizona. We're able to see this at its highest. It'll be due south, average about 40 degrees above the horizon. And generally what we'll see is in middle February, it will show up early in the morning, about 5 o'clock in the morning. And as we go through the months on into July, of course, that time when it is highest in the sky will move to the early evening. It's even to the point now, it's pretty much, you don't see it above the horizon or very little, unless you get down south, maybe down at CAC, they can see it. But pretty much, it was in front of Scorpius, and Scorpius is pretty much setting just about dusk, so we don't see it much anymore. And of course, we don't expect to see it very much this time of the year. Libra is one of the zodiac constellations of the 12. One notable fact, it's the only one that it's an object or a thing. It's not a creature, it's not a character. You'll notice all the others are either animals or some sort of character from mythology. In the case of Libra, it is a thing, and basically it's scales, a balance, and we'll get into that a little bit. The neighboring constellations, and I apologize, I wanted to have the map on this screen, I didn't put it there, but the neighboring constellations are Centaurus, Hydra, Lupus, Ophiuchus, which I believe is a little bit to the west of it, and maybe a little bit north, Scorpius, of course, a little bit to the east of it and south, Serpens Caput, and Virgo. There are no first magnitude stars in this particular constellation. All the stars, the brightest is an apparent magnitude of 2.6, and all the rest are, fainter or dimmer than that. However, there are 83 stars that are at least between magnitude 2.6 and 6.5. So there's a fair amount that can be seen when, especially when the constellation is high in our sky. Unfortunately, and I don't know if any of you have viewed it recently, I spent some time with Libra late last, I think it was probably in the spring a little bit, or last year before it went below the horizon. But when you look towards Tucson, you know, I'm up north of Tucson, of course. Whenever I look at something south, I get washed out by a lot of light pollution. Hopefully it's better for some of you. And I know at some of our dark setups, it's probably much, much better. And you can appreciate, you know, a lot more of these stars in the constellation where, you know, most of what I can see with the unaided eye up here in Oro Valley is only probably about a dozen at best. Anyhow, the constellation is 29th in size compared to the 88. Takes up 538 square degrees in the night sky, and it does have a meteor shower associated with, in May, the Librids. Generally, this constellation can be seen between latitudes plus 65, so considerably up north. And, you know, like I say, during those peak times when it's high in the sky, down to minus 90, of course, which is the South Pole. Makes sense since it is a southern constellation. There are 4 named stars in the constellation. I'll get to those in a little bit. Most of them have Arabic or Middle Eastern nomenclature for them. There are 3 stars with known exoplanets. However, there are no Messier objects in this particular constellation. A little bit about the history as far as the naming and how the constellation came about. It was initially cataloged by Ptolemy in the 2nd century Common Era. In other words, you know, generally what we used to refer to as AD. And the nomenclature today, of course, the Latin is based on the Latin translation coming from the Romans, the weighing scales held by the Greek goddess Dike or Estrella. And at one point, Libra was very heavily associated or related with Scorpius, and somewhat with Virgo, given the fact that these 2 goddesses were believed at one time to be Virgo and represented by Virgo, which is very nearby. Ancient Greeks knew Libra differently, and they called it Kili. And because they associated with, at the time, Scorpius is actually a little bit to the left side of the picture you see there. And some of the principal stars that you see, and not in the way the lines are driven here, but some of the principal stars were associated to be the extended claws of the constellation Scorpius. And so for some time, it was actually associated and was part of Scorpius, however, it was broken out as the years went on. One of the first attributions of the region as scales by the Romans, of course, occurred in the 1st century before the Common Era. The Romans, the Latins attributed a lot of positive feelings and I don't know, culture in the fact that they identified with the scales and the balance of the seasons, the equal length of the day. And one of the things that was noted when Rome was first founded was the presence, the presence of Libra. And so it was a very strong symbol for them. And even, you know, not so much historically, but even the Babylonians back, 1,000 years before, almost 1,000 years before that, also identified this particular setup as being a balance, which is what it is meant to depict. But primarily, most of what we have today, as far as the constellation goes with its name, is related primarily to Roman or Latin backgrounds. Here you can see the constellation, you see the surrounding constellation, you see Scorpius lying off to the south and east of Libra, and you can see where the front of Scorpius moving from Antares off to the west, a little bit north. You can sort of get the idea where the principal stars could be viewed, or you can envision possibly an extension of the front of Scorpius, and these being the claws of the scorpion, particularly the two primary named stars, Zubin al-Shamali and Zubin al-Janubi, which were the ends of the claws, and both Gamma and Sigma Librae were the extension of those arms. But today they're known as being the balance in the scales of Libra, and of course Sigma and Gamma are identified as the arms coming down from that balance, no longer being the claws. But the names of the stars do have their roots in relationship with Scorpius and being the extended claws of that particular constellation.
So Pete, you had mentioned that
Go ahead.
That Scorpius, not Libra, that Libra had some more Babylonian origins. Did you have any more on that? Because I know that most of the zodiacs were known primarily by the Babylonians first, and then transitioned over to the Greeks, and the Greeks get all the credit for doing everything the Babylonians did.
And kind of, there was, I know that there was some information on the Babylonians, and I'm just trying to look at my notes and see if there's anything else here. A lot of it had to do, with, for instance, the Romans were not the first to associate with balance, but the Babylonians were. They had, and I can't pronounce this, but basically they called it Zibana, and the balance of heaven about 1,000 years before that. And so there is some attribution with the Babylonians with respect to the constellation, and it having, here again, going back to what the Romans identified with, the constellation showing balance, scales, balance in the seasons, balance in the day. Here again, another attribution that the Romans had, I think at the time. They identified heavily with the equinoxes when you had equal day and night, particularly the vernal equinox. And that was one thing that was noted, I think, in one particular time with the Romans. But as far as, the actual elements related to the Babylonians, no, I don't have any other information other than the name. There was, the scales were held sacred to the sun god Shamash, which was a Babylonian god at the time. And was identified as the patron of truth and justice. So that's the only other information I noted with respect to the Babylonians and the original nomenclature of the constellation, or how they viewed it.
When you had mentioned the equinoxes, then it kind of clicked to me as like why exactly it's called a scale, because Libra is in a position where it's rising prominently during the spring equinox and setting prominently during the fall equinox.
Exactly,
so
just like those
using one of the many signatures in the night sky in order to be able to tell seasons. So I never really quite fit that with like why it was what the purpose of the scale was, but once you combine that with the timing of the equinoxes, it makes a lot more sense to how it actually got its name, because it seems kind of just like out there. It's just like, why is there this scale here? Why is specifically a scale? But that does make sense when you.
And that's a very good point, because I think even back when you move back to Roman times, when you go back a couple of thousand years, there would have been a little bit more variation. And I suspect, I mentioned that, the constellation was highest in the sky, south at about 40 degrees above the horizon. I think starting in February, it was noted, and that was primarily early in the morning. And then going in through July, of course, those are a little bit offset from the equinoxes, but I might suspect that maybe during that time period, when the constellation was first identified or being looked at by people on the ground, they may have made that association, because perhaps, and I'd have to go back and research it, but there's a good possibility that Virgo might have been in that position more so at the equinoxes and not a month or two earlier. So that was a very good point. So that very well may be. And I think, a lot of times, whether it was Babylonian or the Romans, they had a tendency to connect what was going, I don't want to get into astrology, but connect what was going on in the sky. And it wasn't just the stars, but connect what was going on, in the sky with things occurring on the ground, whether it was a seasonal change, whether or not it was the harvest, whether or not it was some other particular time that they would have noted in their culture at the time. So, no, that's a good point. Thank you. Anything else, folks? So, moving on here again, covering the stars specifically. Like I say, the first one, Zubin-Eshamali. It's Bravo Librae. Here again, the terminology or the name for this particular star makes reference, is an Arabic reference to the northern claw, and like I say, talking about that prior to the Romans, pushing the constellation, and later it becoming more so the balance. This was the nomenclature, for earlier times, primarily around the Middle East. But anyhow, Zubin-Eshamali, or Bravo, or Beta, Bravo, Beta Librae is a blue-white main sequence. You'll notice at the end of the presentation, I've got some of the, one of the things, I've always been a little bit fascinated with stellar classification, not getting too deep into it, but understanding, of course, the first letter designation, which about the stars, the number which makes reference to whether or not it is a hotter or cooler type of that star than the luminosity values. But anyhow, that's at the end of this presentation if you want to take a look at that for reference. Anyhow, for us, it has an apparent magnitude of 2.61. Like I say, it is the brightest star because the brightest star we had at about 2.6, but it's the brightest in Libra. It's 185 light years from our solar system. Turns out that it has a mass 3.5 times our sun, and dimensions, radius dimension 4.9 times our sun, and temperatures have been measured on the surface at 12,300, which is significantly more than our particular sun. When you take a look at the Latin derivation of the name, as far as the northern scale, it comes out as Lanx Borealis, which is the northern scale. So it's one side or one portion of the scale. This particular star is a fairly fast spinner or rotator at about 250 kilometers per second. So there is some light variation. Whether or not that is caused by a companion or because of its rapid speed rotating, it's not sure. The variation in magnitude is rather minor compared to other stars at only 0.03 of apparent magnitude. So whether or not that's based on rotation or a possible companion is still subject to a little bit more study. Another one of the major stars, especially at the, both these first two stars are basically the two stars that identify the two ends of the top balance of the constellation. But Zubin al-Janubi or Alpha Librae, this is a multiple system. The brightest part is a binary. This particular portion is 75 light years from our solar system. It's the second brightest in the constellation. And this particular portion of the name makes reference to the southern claw. And so basically just the other side. And of course, correspondingly, the Latin derivation is Lanx Australis, or the, in this particular case, like say the southern point of the balance, or the southern scale. Anyhow, going back to, like I say, Alpha Librae is a multiple system. The two principal parts, Alpha 1, has an apparent magnitude of about 5.2. It is a spectroscopic binary, so it can't be separated, at least by most Earth-based telescopes that I'm aware of. They're fairly close. And then Alpha 2 has an apparent magnitude of 2.7. It is also a spectroscopic binary. And quite possibly there may be a fifth component of this particular system as far as Alpha Librae, and that's Ku Librae. It's about 2.6 degrees away, and distance-wise is estimated to be a parsec, but has been estimated by astronomers, by those that have researched this particular system, to still be gravitationally bound, so it is part of the system. It's not an optical, but actually part of this system. Given that this particular star Alpha Librae is along the ecliptic, it is possible that it can be occulted by the moon or some of the planets. In fact, for all of you young folks, they're going to be around for another 31 years. Stand by, it's going to be occulted by Mercury in November of 2052. So something to look forward. The third named star in this particular constellation is
Where will we even be to see that? Because that would be below horizon at that time of year. So even if we were around, I don't think anyone would see it unless you're using a space observatory or radio astronomy.
Yeah, that's true. What about in other parts of the planet? Would we?
No, I maybe around the equator, but that'd be hard pressed, because even right now Scorpius is set. Like,
oh yeah, I know Scorpius is set for us, but
like, no, I mean, like, even for like the southern, farther south, Scorpius is generally set this time of the year.
Yeah. But here again, in 30 years, well, and I know there's going to be some motion. I know it isn't going to be a lot, and it probably isn't going to be that significant to make that much of a change. So I think I understand what you're saying. So in all likelihood, it's only something that would be picked up possibly by something in low Earth orbit at a different position. So interesting.
Or our future observatories on the moon.
Yes, there you go.
One can hope.
That's only 31 years,
31 years from yesterday.
Yeah. They're now progging what reestablishing, at least as far as the U.S. is looking, possibly a first landing back or another landing back on the moon by 2025. So what's going to become of it after that, I'm not sure. But anyhow, moving on.
I'll be 99, so maybe I can.
I'll be 96 at that point. So, okay. It'll be kind of interesting. That's a good target to shoot for. Yeah, I want to be around when Zubin al-Janubi is being occulted by Mercury. That works for me. So anyhow, moving on, our third named star in Libra is Brachium, or Sigma Librae. It's a red giant. Latin translation is arm, which makes sense because it sits down at the bottom of one of the balance ends. I think basically in that southwestern portion of the constellation. It's a semi-regular variable on a 20-day cycle, although it has variations over 20 minutes over a 2 or 3 hour period, but it's primarily variations over a 20-day period. Some other notable stars, Upsilon Librae is an orange giant. It's another multiple star system with an apparent magnitude of 3.6, 195 light years from our solar system. Tau Librae, a blue white main sequence star, approximately 367 light years away, magnitude 3.6. And here's the fourth of the named stars. There's even another one down below, but this is one of the principles because it's one of the principles of the constellation, owing to the fact it's the other arm of the scale, and that's Zubin Elecrab, or Gamma Librae. It's another orange giant. So I suspect, one of the main reasons, and these aren't too far away, but of course, this is a particularly large star, larger than our sun. Apparent magnitude 3.9, 152 light years away, but it has about just over 2 times our sun's mass and is 71 times more luminous. Theta Librae, which lies a little bit further south and to the east of Gamma, is another orange giant, very similar in makeup, a little bit dimmer, but about the same distance, basically with respect to our sun, just under 2 times the mass and 35 times as luminous. I won't get into all the rest of these. You can pretty much read these. However, you'll note that down in the bottom, 48 Libra, a blue supergiant. This is a pretty significant and somewhat of an outlier with respect to the stars that are located in this particular constellation. It is I made reference to a star earlier of being a fast spinner at 250 kilometers per second. The rotational speed of this particular star is 400 kilometers per second. Apparent magnitude just under 5, just over 500 light years away, almost 6 times the mass of our sun, and almost 1,000 times the luminosity. It's suspected that there's some variation here, and due to the high rotation, is actually giving off mass to the surrounding area. A couple of other notable stars, and we get into the Gliese, which are primarily stars that are relatively proximate to our solar system, within a few 10 light years as opposed to hundreds of light years. And one of the most notable ones is Gliese 581. You'll notice I've linked a YouTube. I'm not going to play that. It's just a short Discovery Channel bit. It's only about 2.5 minutes. I think it's in fact specifically it's UK Discovery Channel where they talk a little bit about this. I think the date, this is a little bit dated, it was about 10 years old. Anyhow, 581 is a red dwarf. You can see the dimensions. It's considerably smaller than our sun, of course, being a red dwarf, you would expect that. It's about 2 degrees north of Beta Librae. It is a variable, a BY Draconis type. The variation is due to, here again, suspected because of rotation, and there are some star spots associated with this, giving some variation. Now, one of the interesting things about Gliese 581, initially it was one of the first ones where exoplanets were discovered. It's believed to have between 3 and 6 planets. But one of the unique factors about this was one of the systems, in fact, specifically 581c. When you have, of course, I think everyone's familiar, you have the star designation, and usually you have, small alpha characters to designate any exoplanets that have been identified around this particular system. So this would be the third. However, it was the first Earth-like exoplanet or extrasolar planet found in a star's supposedly habitable zone. The habitable zone for this red dwarf, of course, this will be significantly closer in than we are going around our sun, 1 AU or 93 million miles out. How much, I'm not exactly sure. But some very, I found this to be probably one of the most interesting things about the constellation as far as with respect to an individual star. This is the one that caught my attention more than any other. A couple of the other stars, 23 Libra is a yellow dwarf, 85 light years away. I expected to have, a couple of exoplanets. Interesting enough, this star is 8.4 to 11 billion years old, or almost double what our solar system or our planet are. And so it makes you wonder a little bit if there is an Earth-like planet in its habitable zone. It's had twice as long to develop life, and something worth speculation. And you can notice that the star of the sun is very similar to our sun in certain respects. Just slightly over the same mass as our star and only 25% more luminous. Another star, HD, from the Draper catalog, 141937. It's a yellow dwarf expected to have one exoplanet, a massive gas giant. Here again, this star is similar to our sun, and it's about 109 light years away. Gliese 570, also identified as 33G Librae. This is a triple system, 3 stars, about 19 light years away. It's an orange dwarf and 2 red dwarfs. And whether or not I don't think there were any exoplanets identified with this particular one, but this is kind of an interesting system in and of itself, given the uniqueness of having the orange dwarf being in a system with 2 red dwarfs. Okay, probably one of the most notable things, other than when I was talking about Gliese 581, is the Methuselah star, and it's HD 140283. And the unique thing about this particular star, and I'm lost, got to move something here. There we go. It's a yellow subgiant. However, it's been identified as one of the oldest known stars. There are other ones, but this is one of the oldest. It's suspected to be 14.46 billion years old, plus or minus 0.8, so almost a billion years. Okay, so that raises the question, well, how old is, what's the current age of the universe? And I think it's been put at 4.7, 4.8, right? So here you have a star possibly older than the universe. Well, that can't be. Well, there is a degree of error in here, and certainly you throw that in there, and that would pretty much account for it. But anyhow, it's 202, just a little over 202 light years from Earth. The apparent magnitude is 7.2. It is one of the nearest population 2 stars, which are the old stars. Low metal, generally they're found in globular clusters and galactic nuclei. They're older, less luminous, and less luminous than the cooler. Older, less luminous, and cooler than population 1 stars. This particular star, with respect to us being able to see it from here, is invisible to the unaided eye. However, it is twice the size of our sun, almost 5 times more luminous. However, it doesn't have quite the mass, only about 80% of our solar mass. You can see the surface temperature is very similar to our sun. It rotates at a nice, pedestrian 3.9 kilometers per second. And as with most population 2 stars, there are very few heavy elements. This star is almost exclusively hydrogen and helium. There is very little iron content in it. In fact, current research only puts it at less than 1% of our sun's iron content. So it's very low metal content. But the significant thing here is about the age of the star. Now, there have been a linked couple of studies that have been done 7 and 8 years ago. Yeah, 7 and 8 years ago, that deal with trying to judge the ages of stars. Of course, 2 of the primary factors that I think are used as far as being able to judge size, mass, and the flux, which is the energy generated by these particular stars, and not so much the basic flux, but the bolometric flux, where you're looking at the energy being put out at the various wavelengths or the various colors, but really more technically wavelengths. And being able to determine those with greater precision helps a judge more accurately the age. And I think that's something that will probably come with time. However, it is kind of an interesting little story where you potentially have, a particular star that was, formed short, at least what we know now or what we think now was, formed within, probably less than 1 billion years after the Big Bang. So, okay, deep sky objects. You can see, and I've got these pictured. NGC 585 is a barred spiral galaxy. Magnitude 11.8. It was discovered by William Herschel in May of 1784, as was the next one, also a barred spiral galaxy, 12.1 apparent magnitude, about 83 million light years distant. Here again, discovered by Herschel 7 years prior to the, 3 years following his discovery of 5885. Another galaxy, NGC 5890, is an unbarred lenticular, kind of faint, 14.0, discovered by Ormond Stone in April of 1785. And the final featured is not a galaxy, but rather a large globular cluster, magnitude 9, but NGC 5897, approximately 40,000 light years away. It is considered to be a satellite of the Milky Way and is dimensionally about 170 light years across. Okay, one of the things, and this you may find this kind of funny. One of the things I did last year when I was getting back into astronomy, and one of the things that first fascinated me were double stars. Of course, some of them are opticals, but there are a lot of true doubles out there in binary systems. And I was truly fascinated by these, especially when I, after I got my 8-inch scope and started to look at these. What I have here is not a complete list of the doubles that are in Libra, but primarily the doubles, and you can see the delimiters that I used across the top, had to be separation by at least 4 arc seconds, because that's about as tight as I can, resolve these systems. Magnitude of the primary, at least 10, no dimmer than that. And magnitude difference no greater than 4. And you can see when you look, you have the common name of the stars. Some, like in the case of Zubin al-Janubi, that's a double. You have, two magnitude 2.8, magnitude 5.2, and they're separated by almost 100 arc seconds. So this is fairly easy to resolve or split with a positional alignment of about 314 degrees. But you can see there's a couple of others in here that have common names. A lot you'll see names that have never been used. There are various catalogs that have been used over the years to designate double star systems. The one you see, STF, that's primarily Struve. I don't know if most of you have heard of that, but you'll see those a lot. But I find this kind of fascinating. I think when I was taking a second look at Libra back, probably last year sometime, and I think it was earlier in the year, so I was getting up quite early in the morning. But I think I went through just about all these doubles over a couple, 2, 3 nights and found them rather fascinating, fun to look at, especially when, the constellation was high in the sky and they were easy to see. These are the references I used for this particular presentation. And what do we got in the chat? I like that. Thanks, Vanessa. Did you do that intentionally? Who named the dog?
No, my parents named it.
Oh, your parents named it?
But whenever I hear Libra, I think of the
Oh,
dog.
did they name it after the constellation?
Yeah.
Oh, okay. So that was intentional on their part. Anyhow, so that's it for this presentation. Like I say at the, let's see, and, we got locked up. I thought I had my stellar classification. There they are. That's just a reference page, stellar classifications at the end. Any questions about this presentation, folks? Anything else that you want to take a look at?
Yeah, I found it interesting that very old star Methuselah is,
yes,
it's relatively close to us. I would thought it would have been out, out on the outer reaches of the universe. but no, it's only what, 250 light years away?
Yeah. I mean,
Relatively close, you know, it's like,
Yeah.
that's interesting.
yes. No, I thought that was kind of fascinating too. I was, I read, and I took a look at, the two studies. I mean, they are highly technical. About the only thing I could understand were the abstracts and a little bit in the conclusions, not so much the crunches, but some of these factors. And I talked about some of the factors that are looked at that are used to judge the age of a star. Like I say, mass, luminosity, or especially flux, especially when you're taking a look at not so much luminosity as the energy over a period of time, where the flux is energy over a specific area out to a certain distance, which are critical things. But yeah, that was very fascinating. Anything else before I move on to the next one? Okay, let's see if I can make my change now. Bye-bye, Libra. Hello, Norma. Okay, question for everybody. Who's the constellation Norma named after? Any ideas out there? None, no takers? Yeah, it really isn't. At first I thought it was named after someone. Not really, but I suspected, but it really isn't. Actually, Norma is a Latin derivation referring to and I'll get into the history how this particular constellation was named. But anyhow, the second one I'm going to look at is Norma. Of course, it's in the southern sky. Norma is a constellation that we cannot see unless we move considerably further down south.
Peter, if you
But
were
anyhow,
intending to, you're still sharing the Libra presentation?
I am. Uh-oh. Let's see. I'll probably have to get
You
rid
may
of
have
that
to just
then.
cancel the share and then restart it.
Oh, I see. Let me see if I do. Let's see. Let me try
Likely you're
this.
just sharing a specific application, so it's sharing.
Oh, sharing has stopped. So now we can start this all over again. Okay, good. I apologize.
No worries.
Let's go back. Let's see. Share. Okay, if I move back up. Nope. Okay, now do you see Constellation Norma?
Yes.
Okay, very good.
Yeah.
Thank you.
Mhm.
Yeah, I guess I probably should have just linked them together. I thought that might cause a little problem, but that's what we learned tonight. Okay, anyhow, Constellation Norma. This is definitely a southern sky constellation. We can normally, well, we can't see this one unless we probably go, a few hundred miles down into northern Mexico. You might be able to catch glimpses of it. But here again, the name Norma is really a Latin derivation of normal.
Well, this is a
you
Lacaille
see-
constellation, so that explains the
Yes,
name.
yes. And you'll see it was introduced by Nikolai Louis de Lacaille. He was the one that mapped these. He did this during the middle 18th century, the middle 1700s, while he was mapping the skies. And I think he gave names to, or initiated names to, a couple of other constellations that he drew down there. But
So
this was based on.
for those
Go
unfamiliar with Lacaille, from other presentations
ahead.
we've done, Lacaille was a cataloger of about like 19 southern constellations, and he assigned them all names after various scientific instruments from the Renaissance or Reformation periods. So if it's cataloged by Lacaille, it's usually from along those lines.
Yeah, for instance, like microscopium and telescopium. Those were two that were probably done by him.
Horologium.
Yeah. I think he did almost 10, 11 or a dozen constellations
I think it's like
along those
18.
lines. Yeah. But anyhow, that's where the name is derived from, normal in Latin. Here again, designating a right angle, level, set square, or a Carpenter square. Even though when you look at the star map excerpt, it looks like it's a not a square, but slightly askance square. Not just a Carpenter square, because normally a Carpenter square just has two sides on it, not four. But anyhow, it's a rather small constellation, 74th out of 88, 165 square degrees, and can be seen between latitudes like say plus 30 down to minus 90, of course. And plus 30 isn't, it's only about 120 miles south of 120 nautical miles south of us, maybe a little bit further. So down in northern Mexico, you could probably start to pick this up. Of course, it becomes much more visible the further south you go. Neighboring constellations: Ara, Cincinus, Lupus, Scorpius, and Triangulum Austral. You'll notice I have a tendency to sometimes put my pronunciations in the presentation just so I wouldn't mess them up too much. There are no formally named stars in this particular constellation. They just have numbers or Greek letter designations. There are 4 stars with known exoplanets. There are no Messier objects. The brightest star, Gamma 2 Normae, has an apparent magnitude of 4, so all the rest of them are dimmer than that. Nothing really to base it on because I've never seen it, not something I've looked at. Maybe someday when I plan that first trip down to the Atacama Desert. Anyhow, there is a very, I don't want to say weak, but nondescript, weak, probably is the best way to put it, meteor shower associated with this particular constellation, the Gamma Nomedes. It does radiate out from Gamma 2 down in that lower southeastern corner of the constellation. Some notable stars, already talked a little bit about Gamma Normae. There are 2. It's an optical double, not a true double, not a binary. They just look close together. Gamma 2 is in and of itself is a close optical binary. It's a yellow giant, magnitude 4, about 127 light years away. Gamma 1 is a yellow-white supergiant, magnitude 5, but here you can see the discrepant distance compared to Gamma 2. It's over 1,400 light years away. So there's no way that these 2 are a binary. They're just an optical double. Epsilon Normae is a binary, white main sequence, magnitude just over 4, about 400 light years away. It lies in that northeastern side, northeastern portion of the constellation. Iota 1 Normae is a white subgiant, about 140 light years away. It's a multiple system. Eta Normae is a yellow giant, 218 light years. And you can see a lot of these stars, with the exception of Gamma 1 so far, aren't exceptionally distant from our solar system. Yeah, it's a couple hundred light years, but if you understand big numbers, this is actually relatively pretty small. And then, of course, we have Delta Normae as a white A-class, about 123 light years away. Keying in a little bit on Mu Normae, and you'll see there's another note down there. It is one of the most luminous known stars. There's a widely discrepant estimate of its luminosity, primarily based on the fact that it lies in a part of our galaxy that is heavily obstructed with dust in the center part of the galaxy. Creates that problem. You'll see that it has basically, and there'll be another note down below here, but basically it's estimated that its luminosity is between 250,000 and 1 million times our own sun. So this is pretty significant. And it is a variable too, because you'll see it's an alpha Cygni type variable, varies between 4.87 and 4.98. Not real big, but something that might be noticeable, definitely, probably more so measurable with the right equipment. It's a blue-white supergiant. over 4,600 light years away. Oops, okay. Oh, God, I lost my notes. I'm sorry. Mass, 30 times our sun, a radius 15 times our sun. Mostly these first few stars up here, these are all variable types. There's a Mira type, R Normae. This has wide variation, 6.5 to 13.9 over 507 days over that period. That's a pulsating red giant, about 600 light years away. And then finally, a Cepheid variable, S Normae, 6.12 to 6.77, and that's over slightly less than 10-day period. A couple of stars that have exoplanets, that are hosting exoplanets, HD 142, 415, yellow main sequence. Here you'll notice it's somewhat similar to our sun with respect to mass and luminosity. It has a Jupiter-like planet with a period of 386 days. Sounds like an Earth-type year. Whether or not it's that distance out, I don't know. Another star, HD 148156, another yellow main sequence here again, similar to our sun, has a gas giant slightly smaller than Jupiter on a 1,000 plus day orbit. HD 143361 is a binary, 210 light years away, has a planet 3 times the size of Jupiter in a similar day orbit, and this one, 1,057 days. And then finally, HD 330075 is another yellow dwarf. Here again, similar to our sun, 164 light years away, that has a hot Jupiter. It's in close. You'll notice the period around that particular star is only it's under 3.5 days. So more, no doubt, it's going to be fairly close in. Now, as we got into Norma, pretty much nondescript, pretty much pedestrian with respect to stars in the system. However, it's got some pretty interesting deep sky objects. The first, and you'll see it, I actually have a picture of it there, the Ant Nebula, or Menzel 3, is a bipolar planetary nebula, 13.8 apparent magnitude. It's 8,000 light years away. It was discovered by David Howard Menzel. It's also referred to as Menzel 3. He had a catalog going in 1922. And you can see it sort of resembles a little bit like an ant. You can see the thorax and the head of an ant looking horizontally. NGC 6067 is an open cluster, about 4,600 light years away. Nice thing about this, if you happen to be where you can see this constellation, it is viewable with binoculars, because the cluster is about 12 arc minutes across and bright enough. You can see the apparent magnitude 5.6, so something that could probably readily be observed with binoculars, probably at least maybe 10 by 50s. S Norma cluster, or NGC 6087. This is also depicted just to the right of it. You see a bright star, but it's actually an open cluster that has about 40 or more stars. Magnitude 5.4. It's 3,500 light years away. Here again, might be seen quite readily with binoculars because it's 15 arc minutes across. The Fine Ring Nebula, or Shapley 1, and this is depicted in the picture on the far right of this particular slide, is an annular planetary nebula, magnitude 12.6, about 1,000 light years away, or covers, if you're viewing, about just over one arc minute angular distance. And this was discovered by Harlow Shapley in 1936. The Norma cluster, and you can all see that picture down in the bottom, correct? Okay. And this is kind of the more fascinating one. I think this picture was taken by the Hubble, but the Norma cluster is a galaxy cluster, and there's actually a galaxy in the foreground of this cluster. But you'll notice it's just 221 million light years. Okay, so of course it's well outside the Milky Way, but it is heavily obscured by the Milky Way. One thing, this has been identified, and it lies in what's referred to as the Great Attractor. This has been what the Great Attractor is a gravitational anomaly in intergalactic space in this particular area, but it's believed that the attractor may have spatially within, of course, this is going to extend over probably hundreds of light years, up to the mass of 10,000 galaxies. So it's pretty significant as far as a particular area. And like I say, this is one of the pictures that the Hubble took. Finally, closing out the last two, Menzel 1 is a bipolar planetary nebula, about 3,400 light years away. And I've got to move something on my screen. And then there's a couple of other open clusters. I just botched these together: NGC 6021, 6167, and 6152. And so that pretty much does it for most of the deep sky objects in Norma and references for that particular one. And that brings me to the end of my presentation. So let's see, I'm going to stop sharing. Unless there's someone, does anyone want to see anything particular off any of the presentations before I stop sharing? No? Okay, I'm going to stop sharing. And that's it. Questions, comments?
Thank you very much, Peter.
You're welcome, Connor. Thank you. Thank you all.
Thank you.
And with that, I'm going to go ahead and end the recording because that's all we have for presentations. And if anyone wants to just stick around and have, free floor discussions, by all means, go for it.